In this lesson, I want to talk about some problems with data types and arithmetic in C++. And they're not so much problems as just things that you need to be aware of when you're doing arithmetic in C++. Let me start with the most obvious, or not obvious, but one of the simplest problems that comes up a lot. And that's going to be what we call integer division. So take a look at this statement, Cout 7 divided by 3. You expect the answer to be 2.5, but watch what happens when we run the program. The result is actually 2, and that is because C++ uses what's called integer division, which means that if you divide two integers, you're going to get an integer result. All you have to do is make either the numerator or the denominator, either operand, a floating point number. Now when we run the program, we get a result. Notice also that that was not necessarily the result that you expect. Let's do this again. This time let's use and let's put it into a variable. So let's see what we get when we run this program. Notice what we did. We created num, or numerator, as an integer, assigned it the value 7, declared denominator, or denom, as a double, assigned it the value 3.0, quotient, a double, then gets the result of dividing numerator by denominator, and then we display the quotient to the screen. And so notice we get 2.333. So there's a little bit of precision errors going on with that also. Let's try one more thing. Let's try it again with two doubles. And so you see we're still getting the same thing. So there's a little bit of an issue there. So you have to be really careful when you're doing floating point arithmetic. Now, another point I want to bring up is a little different, but the same kind of problem. Oops. So notice what I've done. I've declared num as an integer variable and assigned it the value 1. Then I display it, simple enough. Then I reassign 1.5 to num, and then I display it again. Think for a second about what is going to happen. If you need to, even pause this video, and then let's run the program and see what we actually get. So notice that when I assigned 1.5 to num, it took that number, even though 1.5 is a floating point literal, and stored the truncated version, just the 1, in num because num is an integer variable. So what we say is we say that C++ performs narrowing conversions, or it can perform a narrowing conversion, where it takes a floating point value and converts it by narrowing it down to the integer, cutting off the floating point part, and assigning just the integer to the variable. Let's take a look at the other version of that. We'll call this denom. Let's comment out the first part of this, just because we've already seen how that goes. In case we haven't seen this before, we can use what's called C-style comments to comment out a whole block of text. So I write /* at the beginning of the comment, and then */ at the end of the comment, and that comments out a whole block. Now, back to the problem at hand. Let's see what happens when we run this program. Notice we still get 2 and we still get 3. This is what is called, right here, a widening conversion. And all that means is that when we try to put an integer into a double variable, it widens that to 3.0, although you don't see that in the output. That's just because C++, this particular compiler, code blocks, does not display the 0.0. It's there, you just don't see it because it's not displayed. We assigned it right here. And we could have assigned it there, but we didn't, and implicitly, C++ converted that to a 3.0. So the two things you need to watch out for are integer division, where you divide one integer by the other and you don't get a floating point or a fractional part, is what I really should say. And then narrowing conversions, where you store floating point values in integer variables, and the compiler accepts that, and it just truncates the fractional part and leaves you with just the whole integer. I should mention that other languages, or more modern languages, languages that have been developed since C++, do not perform narrowing conversions and will give you an error, such as Java and C#, when you try to store a floating point value in a declared integer variable. But in C++ you can do that, so you need to watch out and be careful for how you mix your arithmetic types, your data types, your numeric data types when you're working with C++.